Hello everyone, this is Mr. 13 Things, or Sounds Did Good, depending on which channel I'm choosing to upload this video. And what I'm going to do here is we're going to talk in the middle of our Quaternion discussion about where these things start to line up in terms of using things like calculators. So what I'm going to show you is quaternions are vectors, and vectors and matrices kind of work together. So you'll see later on, especially if you get out to MIT, how much stuff that you're doing potentially in high school could be done a lot quicker. I'm going to show you the first one just to show you the kind of thing you might want to look into, especially once you get beyond your exams, your ACTs, SATs, to kind of delve into the math that they've been hiding from you, if you would. And that's just to show you within the calculator a couple things you want to do when you turn on a calculator. Like any machine, you want to click on some things that you know the answer to. My personal favorite is e to the I pi. So what I can do here is go second e, and then you got to also realize you got to learn to over parenthesize. There's that opening. That's to the power, and I'm going to go second I. And then one of the great terrible things about this calculator is that pi is a second function as well. As I hit that, that's looking pretty close to -1, but that's only because things are set up to radian. So you have to realize that that should be -1, and it is, but when you run that, it gives you a bit of an error. But you want to make sure that you turn on a calculator, make sure that your settings are all set correctly. What I'm going to do here is I'm going to hit second quit, and I'm going to hit clear. What I'm going to do is going to fill up these vectors into two vectors, vector A and vector B. A vector in a calculator like this is just a matrix of one column. So forgive me if I get some of these wrong, but I'm going to plug a little bit into the calculator on the side here. A calculator like this does not allow you to kind of put things in exact. In other words, it doesn't carry around square root of 3. It carries around a float value of that. Many of you may recognize the square root of 3 over 2, and you should start at 0.866. And the square root of 3 over 2 would be 0.866 divided by 2. And I'm going to plug those numbers in now into matrix A. So I'm going to go to second matrix. I'm going to go to edit. And matrix A is going to be a 4 by 1. The first value is going to be 0.866. Go down here. The second value is 0.25. Go down there. The third value is 0.866 over 2, so I can do that. 0.866 divided by 2. And the last value is 0. So I have now in matrix A, I have that set of numbers. I'm going to go into matrix B now. So I go second matrix. I go over to edit, and I'm going to go down to B, and I hit enter. And that's once again going to be a 4 by 1. The values now are going to be 0, 1, 0. Go back up to the top. 0, 1, 0, 0. Second quit. Now what you're going to see in a calculator, there's a couple different ways to multiply. Let's just see if we multiply A times B, what happens. If I go second matrix A times second matrix B, what do I get? A mismatch. So then there are two ways to multiply this. I can go A transpose B. Maybe I'll try that. Second matrix, I go to math. Go to A, and then I go to second matrix math transpose, and then second matrix B, and I get a value which is not what I want. If you remember, I want to get a 16 plus matrix. So what's the other way to do that? Maybe it's second matrix A times second matrix B, second matrix math transpose. Now, it's an unfortunate thing, that's the way the calculator works, but once you start doing this on a regular basis, you can see it's just a rhythm thing. As I hit that, I realize I get something close to what I had here. So what's the other way I could have done it? It could have been B times A transpose. So let me see that. Second matrix B times second matrix A second matrix math transpose. And if you see that now, we hack essentially, and I'm going to go ahead and point out that we have the values that we had calculated by hand. That's about half of 0.866. So, not that you're going to remember essentially that's the order that you do things, but you can start to realize here how you, if you wanted to do quaternion calculations on your calculator, you could use the ability of multiplying vectors by vectors or vectors by transpose vectors and pull out the particular values here. So for instance here right now, what I could do is I could take this value and throw that next bit, if you would, I could take the places that we're getting values and plug them up here into the, if we want to call it the middle part of this calculation. So in other words, the 0.25 from here ended up going there, 0.866 went there, and 0.433 went there, but then you had the positives and negatives. So you can start to see that this calculator has more going on than you might otherwise think. What I do want to show out, just to, so the end would realize you can use something that you can definitely use, is let's think about a vector that's just a three-place vector. That's 3, 4, 5. And so I'm going to go here, second matrix, turn this back on, and I'm going to go second matrix, and I'm going to go to matrix C. I'm going to edit it. You got to go back to it, hit the edit. I'm going to make it a three-place vector. And this is a nice one to know. It's Pythagorean triple, 3, 4, 5. Now if you want to know what the magnitude of that vector is, it would be the square root of 3 squared plus 4 squared plus 5 squared. And later on you're going to see how this can be used to keep track of three-dimensional points. And in TI83, when you get up to an 86 or an 89, it probably deals directly with three-dimensional vectors. But that said, you can do second quit here. And now what you do to get the magnitude squared, you take in second matrix transposed. Second quit, sorry, go. Second matrix, we're going to take C, and we're going to transpose it, which makes it a row vector by going to math transpose. And we multiply that by itself, or the original vector C. And when you'll get a single place number, which is 50. So if you took the square root of 50, that would in fact would be the magnitude of the vector. So the square root of 50 is the magnitude of the vector. Once again, you remember 3 squared is 9, 4 squared is 16, and 5 squared is 25. Therefore, you add those together, you got 50. So a really fast, great way to figure out Pythagorean theorem calculations is using the calculation that the magnitude of a vector is the column vector transpose times the column vector. That gets you the square of the magnitude, then you take the square root. You'll see later on there's useful understanding in that. But what I want to show here is that you can learn to kind of do one or two hand calculations and then figure out how to get machines to do it. On the quaternion calculation, if you're doing them a lot, you'll obviously want to write a program, which in fact is done right in here if you wanted to go through in your calculator and start writing programs. As soon as if you're in 7th or 8th grade, start learning to program your calculator and get used to using it programmed or not programmed. Once you've taken your exams, if you're in that middle high school, you want to start using this each and every day for as many classes as you can. If nothing else, because it just gets you used to the fact that programming is not a voodoo science. It's relatively straightforward, especially if you get out into the web and share. In the end, you won't be programming most likely in BASIC, but it's not a bad place to start for a number of reasons. Mostly because these calculators are allowed on your standard exams. Thanks for listening.